Brought to you by My Green Egypt, green resources for efficient energy.
Hi, this was supposed to be the second video that we were planning to reverse engineer the Wellsee MPPT battery charger, and this is the internal power circuit board. And I started reverse engineering the circuit board, and then I started with the power transistors. This is a common approach that I usually take when I reverse engineer any power circuit. And quite frankly, I was a bit disappointed because the circuit diagram that I drew on this paper, as you can see, yes, I discovered that the solar panel was connected to a MOSFET transistor, and then the MOSFET transistor had some sort of a transition transistor, another MOSFET transistor, and then the last transistor was connected to a final transistor that connected the ground of the solar panel to the ground of the batteries. And I guess one of those transistors is performing the real PWMing, and the rest are protections, short circuit protections, and performing functionalities like that. And from what I saw of the routing on the circuit board, that some of the traces are extremely thick, and then the trace would continue really thin on the rest of the board. So if you are making it thick and you are putting solder on it in order for the trace to carry a large amount of current, then when you continue the trace on the board really thin, that means that this trace would burn out eventually. And something else is the inductor. If you remember from the previous video, when we were measuring the output voltage and we saw it fluctuating, and I speculated that the input inductor would be small. I measured the inductance using this inductance meter, and I adjusted the range of the inductance to the lowest value, which was on the meter 2 millihenry. And the meter can measure to a 1/1000 fraction of this value, so even the inductor was below 0.001 millihenry, which that means the inductor is really small. And if you want to get a decent result in terms of the output ripple current, you have to operate on a really high frequency, and that means operating in the order of megahertz. And I guess given the internal microcontroller of the device on the control circuit board, the microcontroller is a big microcontroller, and the big microcontroller can't generate PWM on that frequency. Big microcontrollers typically work or operate at a maximum 24 megahertz crystals divided by 4, and that means the machine cycle, the clock frequency would be 6 megahertz. This is not enough to generate 500 kilohertz output frequency on the PWM. So after seeing that, I decided that I'm not going to continue with my reverse engineering, and this doesn't actually worth the effort in reverse engineering this product. And to be frank, this is what you would expect from a Chinese solar charger. So we'll try to avoid all of those mistakes in our future designs in My Green Egypt solar chargers, and we'll try to make it better. And also we'll try to keep the cost down, but not on the expense of the quality or the performance of the device. So until we see you in the next video, if you have any question, please leave your comment in the comment section below, and stay in touch. See you in the next video, and goodbye.